This is Dr. Holt. This is a very short video lesson on how to calculate the center of mass. The center of mass represents the average position of the mass of a system. Let's say we have three particles, M1, M2, and M3. We want to find approximately somewhere in here where the center of mass would be of this system itself. All we have to do is we take each mass and we multiply it by the x-coordinate here. So in this example, I take M1 times x1 plus M2 times x2 plus M3 times x3. That becomes the summation of my numerator. And then all I have to do is divide it by the summation of each of the masses added together. That will give me the center of mass of the system. Now when you get in something that's two-dimensional, all you have to do on this case is do the x-coordinates first. So I would take the 70 times the 4 plus the 60 times the 14 plus the 82 times 30 divided by the summation of the masses. That will give me the x-coordinate. And then to do the y, I would take the 70 times, and you can do it, make it negative if you want to, 70 times negative 9 plus 60 times negative 14 plus 82 times negative 6. I will divide that by the summation of the masses, and that will give me the y-coordinate. Now the center mass can also be worked in a three-dimensional system here, where you have three masses, but they're all say in an x, y, and z coordinate. If you do that, just do the x's separately. So we just take M1 times x1 plus M2 times x2 plus M3 times x3 and divide it by the summation of the masses. And I would do the same thing for the y and the z, and that would give me the coordinates of the center of mass of this system itself. You also can write it in a sigma notation, and it works exactly the same way. I'll just go through a quick example doing a three-dimensional system. Here I have three masses, a 6, a 12, and an 8. I have position vectors for each. So I will use the sigma notation, and to find the center mass, I will take the 6 times the 3 plus the 12 times the minus 4 plus the 8 times the 10. I will divide it by the summation of the masses, which in this case will be 26, and I will get a value of 1.92. I follow the same approach with the y. I take the 6 times 0 plus 12 times 3 plus 8 times 5, and again divided by the summation, which is 26, and I'll get 2.92. And then to do the k value, I will take 6 times minus 2 plus 12 times 8 plus 8 times 12, and again divided by 26, I will get 6.92. So now I can write the center mass as a vector, or as a position vector, as 1.92 I hat plus 2.92 j hat plus 6.92 k hat. So that's the end of this little lecture. Again, it's very short, but it goes over the basics for finding and when you're dealing with one-dimensional, two-dimensional, and three-dimensional.